The purpose of this video is to learn about how to evaluate Boolean expressions, how relational comparison operators work, how to use AND and OR logic, how to make selections with ranges, and then also the precedence that occurs when combining AND and OR statements. We're going to start talking about Boolean expressions. Now, a Boolean expression is just simply one where we compare one element to another one and see if they're equal or not equal. And we have three possible conditions. One is that the two things are equal. One is that one is greater than the other one, or one is less than the other one, or that we could end up with what's called an illegal operation. If I'm trying to compare two numbers together, I want to see if the number 3 is equal to the number 5. That's false. That's one of our conditionals. We have something like 3 is equal to 3. That's true. If I do something like 3 equal to Bob, those are two completely different data types, and I can't actually perform that comparison. So that is actually an illegal operation. So what we're going to do is we're going to compare these. So I want to take a number 3 and compare it to 5. And so if I say is 3 less than 5, that's true. If I say is 3 equal to 5, that's false. If I say is 3 greater than 5, that is also false. So the whole purpose of these Boolean expressions is strictly to see if the two values are equal to each other or not. Now, we can control how we want it to be true or false. So sometimes we'll want the two things to be equal. Sometimes we'll want the first number to be greater than the second number. Sometimes we want the first number to be less than the second one. Or we want it to be just simply that they're not equal to each other. Or they could be greater than or equal to, or less than or equal to. So we have all these different operators that we can use. We can have the equal sign, which is our equivalency operator. Now the equivalency operator just simply means that we're trying to see if the two values are equal to each other. If they are, that's true. Now in Raptor we're going to use one equal sign to see if two things are equal to each other, but some programming languages will require two equal signs. So when we get into C# later in the semester, you'll see that we can't just simply use one equal sign to see if two things are equal to each other, because one equal sign sometimes means an assignment operator, which means that we're assigning a value to a variable. Alright, so I have greater than, less than, and then this is greater than or equal to. This one is less than or equal to, and then this one is not equal to. And essentially, if you think about it, if something is less than and greater than, then that would actually make that condition true. So what we're trying to do is we're just simply trying to see if two things are equal to each other. If they are, then we can do something as some sort of outcome from it. We're going to use these in selection statements. We're going to use these in if-then statements. So if 3 is less than 5, then do something. If 3 is not less than 5, then we'll do something else. So we have our single alternative and our dual alternatives that will be available to us later in the semester. So what you'll see is we're going to start trying to compare things so that we can make decisions. So what I want to do is I want to see if this person's customer age is greater than or equal to 65, then we're going to give them a discount of 10%. That's what this means right here. So 0.10 is the same as 10%. If they're not older than 65, so meaning if this is true, we do this. If this is not true, then we do this thing down here. It's called an else statement. So what I can do is I can tell you something like, if you are hungry, go get a sandwich. Else, either don't do anything or do something else. So if you're hungry, go get a sandwich. Else, go sit on the couch. If you're thirsty, go get a drink. Else, go outside. So those are our options. So I'm comparing. If it's true, then do this first thing. If it's not true, then we do the second thing. And this is called a dual alternative statement. We covered these in the last lesson. But in Raptor, you actually see this as a selection statement. This is how we would write it out as pseudocode. So we're going to say if the customer's age is greater than or equal to 65, then give them a discount. Otherwise, don't give them a discount. So if they're not older than 65, then we don't want to give them the discount. Now we could do it the other way around. This is the exact opposite. So if the customer age is less than 65, then we're not going to give them a discount. Otherwise, which means they are older than 65, then we will give them a discount. So these two actually say the exact same thing, but by simply changing the comparison, we change whether we want to look at the true side or the false side. Sometimes we want to evaluate for the true side, sometimes we want to evaluate for the false side, and it just depends on the program that we're trying to design. Now, what I will caution you is get in the habit of trying to evaluate for the true side. So if I want to give them a discount, then we're going to try to see if they're old enough to get the discount. And if they are, then we give them the discount. If they're not, then we won't give them the discount. It'll make it much easier to troubleshoot your code for these upcoming assignments. Now, the actual flow chart for this is a selection of statement. It looks the same in in Raptor. But in Raptor, what you'll notice is that the yes and no sides are actually backwards. So pay attention to that when you are writing your programs in Raptor, that you know that this is the yes side and this is actually the no side. So what this program is doing is they're looking at some sort of customer code, and this symbol right here is the not equal to symbol. So we're trying to see if this customer code is not equal to 1, then we're going to give them a discount. If it is equal to 1, meaning it's not equal to 1, double negative. So if it's not equal to 1, then we're going to go to this side and we're going to give them a bigger discount. So it would look like this if we were to write it out as pseudocode. So if the customer code is not equal to 1, then their discount is 25%. But if their customer code is equal to 1, meaning the opposite, then we would give them a discount of 50%. We can use the not operator in most programming languages, and the way that we do this is we're actually combining two statements together. We're trying to see if their age is less than 21 and their age is over 21. Or we could say, is their age less than 21 or is their age more than 21? And what that allows us to do is actually compare the numbers and combine those together in one statement. So what we're doing is we're looking at their age, and if their age is less than 21 or their age is greater than 21, that's the same as saying not equal to. Many programming languages will use this. Some of your programming languages will use an exclamation point and then an equal sign. So you just have to know the actual syntax for the programming language that you're using. Alright, so we want to get rid of double negatives. And what this means is that I want to try to evaluate for something to be true. Alright, so in this case we're looking at, is the customer code equal to 1? So now this is a little bit easier to see. So I can come in and say, is the customer code equal to 1? If it is, we give them a 50% discount. If it is not, then we give them a 25% discount. So these are effectively doing the exact same thing. They're just complete opposites. So if I look at, is the customer code equal to 1, and put the discount of the 50% discount on the yes side, or I do, is it not equal to 1, and put the 50% discount on the no side, they actually evaluate for the same thing. But what I want to try to avoid is this not. It gets really confusing, especially as our programs get more complex. One of the common issues is incorrectly using the greater than or equal to, or less than or equal to. And the reason for it is I have to evaluate this thing called a limit. So I'm going to give you an example of if a person is 18 or older, then they're old enough to vote. So what that means is that if their age is 18, they're old enough to vote. If they're 19, 20, 21, 22, anything over 18, they're allowed to vote. But if they're 18 exactly, they're still allowed to vote. And what will happen a lot of times is that people will actually write their program in such a way that they'll say, if their age is greater than 18, then they can vote. And what will happen is if I try to evaluate it and I type in an age of 18, 18 is not greater than 18. So what would happen is if I tell it that the person's age is 18, they're not going to be old enough to vote. It won't let them do it. So whenever we do these, we want to test our limit. And what that means is that if I'm testing something, I want to see if somebody's old enough to drink. So you have to be 21 to drink or older. So they have to be greater than or equal to 21. Well, if I said that their age has to be greater than or equal to 21, then I want to type in the age of 21 when I run my program. So if my program asks, how old are you? And I type in 18, it should tell me I'm too young to drink. If I type in an age of 20, it should tell me that I'm too young to drink. I always want to test my limit and the number above it and the number below it. So what I'm going to do is I know my limit is 21. So if I were to type in 21, I should get that I'm old enough to drink. If I type in 22, I should get that I'm old enough to drink. If I type in 20, I should get that I'm not. But if for some reason I type in 21 and it says that I'm not old enough to drink, then I have my comparison operator wrong. Instead of a greater than, I would want it to be a greater than or equal to. Now I can evaluate to see if more than one condition is true. So I could say if you are greater than 13 and less than 20, then you are a teenager. And actually I did that wrong because it should be if you are greater than or equal to 13 and less than 20, then you're a teenager. What I can do is I can evaluate two things at the same time to try to make a decision. And I can actually compare the two. I'll look at this, and if I type in a number of 15, so let's say I tell it that my age is 15. Okay, I'm greater than or equal to 13, that one's true. I am less than 20, that one's true. Therefore, they're both true, and my entire thing will evaluate as true. Now, an and statement means that both conditions have to be true. I could also do it another way. Instead of using an and, I could use an or. So I could say something like, if your age is less than 3, you get a discount, or if your age is greater than 65, you get a discount. Alright, so if I type in that my age is 2, my age is less than 3, so I get the discount. If my age is more than 65, let's say I type in 67, that would be true, I get the discount. And the way that an or statement works is if either one of them is true, then the whole thing is true. So an and statement, both of them have to be true. An or statement, only one of them has to be true. So we end up with these things called a truth table. And the purpose of a truth table is to tell us how things evaluate. So our truth table looks like this. Now what this is that I have an and, this is an and table. We will also have an or table. And the way that it works is I have the first condition, we'll call it X, and our second condition is Y. So if the person is greater than or equal to 13 and their age is less than 20, then something will be true. Okay, so if I type in 15, their age is greater than 13, so that would be true. Their age is less than 20, so that's true. So therefore the whole thing is true. If both of those are true, then the whole thing is true. But if I type in something like the age is 21, okay, what would happen is if I evaluate is their age greater than or equal to 13, that's true. But if I try to compare it to less than 20, that's false. Because both of these are not true, then the whole thing is false. Same thing the other way. If I were to type in that my age was 5, I'm not older than 13, but I am younger than 20. So even though this one's true, because this one's false, the whole thing is going to be false. And then likewise, if I type in something that both of these is false, which in this example wouldn't necessarily work, but if I type in something where both of these is false, then everything would be false. So what you need to know is the way that the truth table works, so that way you can learn how to try to combine these queries, these conditions together to see if the outcome is true or false. The OR conditional operator works the opposite. So if I evaluate in the scenario where I wanted to look at somebody's age, if they're less than 3 or older than 65, they get a discount. If I type in an age of 2, the first one here would be less than 3, so that's true. But if I evaluate the second one, is their age greater than 65, well, that would be false. So that would be this one. So the first condition is true, the second condition is false, but because an OR truth table comes out where if either one of these is true, then the whole thing is true. So I want to give a discount. So if the person is less than 3 or greater than 65, then I can give them a discount. So they're less than 3, but they're not older than 65, but they still get the discount. So the way that it works with an OR table is either one of the conditionals evaluates as true, then the whole thing evaluates as true. In the AND table, they both have to evaluate as true for any of it to come through as true. We're going to start using these to be able to verify what's called a range check. And what a range check is just simply that I want to verify if something exists within a range. So I want to see if I ask you to enter a number between 1 and 10, I want to see if that number is between 1 and 10. So what I can do is, if the number is greater than or equal to 1 and less than or equal to 10, then we will do something. But if it's not, then maybe we throw an error and say, hey, you didn't type the number within the correct range. So a range check is just simply allowing us to see how much of a range we can have and still be true. Now we'll also use a range check for something like, in this case, this scenario here, it shows that depending on the number of things that are ordered, you get a discount, and the more things you order, so we can check that range. Where you'll actually see this is going to be trying to figure out somebody's grades. So if I want to see if somebody's grade is an A, a B, a C, a D, or an F, or an E, depending on which college you're going to, I can evaluate those ranges, and I can see if they're an A or a B or C or D or anything. So what I'm going to do is I'm going to ask somebody, what is your grade? And let's say the person types in a grade of 76. Then what I'm going to do is I'm going to first evaluate to see if they made an A. So what I'll do is I'll make a selection statement that says if the grade is between 90 and 100, so if the grade is greater than or equal to 90 and less than 100, then they made an A. Then if they didn't, because this one evaluated as false because they got a 76, then in this case that's false. So that what we want to do is we want to go in and look at another range. So then we'll make another if statement. So if their grade is between 80 and 89, then they got a B. Well, in this case they didn't, so we're going to evaluate again. Okay, so what we're going to do is we're going to end up with this thing called a cascading selection statement. And what this will allow us to do is look at ranges to try to evaluate to see what kind of grade this person earned based on the score that they entered into the system. Some of the problems that will be caused by doing these cascading selection statements are that you can actually create a logic error where the person will never actually evaluate to any of those ranges. Especially if I did something like if the grade is greater than 90 and less than 100 and the person enters a 90, then what can happen is that their grade should have been an A, but we used the wrong conditional and it rolls over into the B section. Alright, so then we look at the B section and then we say, okay, well, if the grade is greater than 80 and less than 90, well, it's not a B. So let's go into the C section. Is it greater than 70 and less than 79? Well, what's happening is we're actually excluding all of the even values. So what I'm talking about is like 90, 80, 70, and so forth because we used the wrong conditional. So what we need to pay attention to is that I need to make sure that it is possible for that person to get into every range. And if they can't, then I need to fix my conditionals. Most programming languages will allow us to use ands and ors in the same statement. And what will happen is the system will evaluate the ands before it evaluates any of the ors. Now we can control the order that it actually evaluates them, just like we do in math class when we're doing an arithmetic function. We can use parentheses, and if we put parentheses around our ands and ors in a specific way, we have more control over how they actually get evaluated. One of the things that you'll see is that by combining ands and ors together, and by using nested selection statements, we actually run into a problem where we can actually not necessarily get into the right range. Maybe we evaluate wrong and we get the wrong answer. So if I'm going to ask somebody for the grade and they enter 97 and for some reason the system says that they earned a C, well, what that means is that the system evaluated their grade incorrectly because we had a logic error in the system. Alright, so we're going to start designing the programs that I've talked about. So we're going to see if somebody's old enough to vote and see if somebody's old enough to drink, and then we'll see if they get a discount, so they're less than 3 or over 65, or I want to see if somebody's a teenager. We have a couple other programs that we're going to be building. Remember, you're to build every one of these programs and submit them to be your proof that you watched the video. You have to do these or you don't receive any credit for any of the other assignments. So what I've done is I've created a Chapter 3 folder under my Lessons folder, and inside of here I'm going to start building some programs. Alright, so I'm going to build a program and we're going to ask the user for some input. So I want to ask the user, how old are you? We're going to take that value and put it into a number, and then we're going to evaluate to see if that number is equal to or greater than a number. Okay, so what I need to do is I want to evaluate if they're old enough. So we're going to see if they're old enough to vote. Alright, so I want to make an input, and it does say to save. Make sure you do your comments, make sure you save it. So Chapter 3. Now remember, the naming scheme is last name underscore, this is week 4 underscore number 1. Alright, so put my comments in. So my comment here is going to be my name, CIT 120. We are on 9/4/2015, and then this program is going to be old enough to vote. Okay, so that's our comment block. Now, you're going to put comments for every one of your blocks just like you've been doing. Some people have been asking about, how do I put the comments in? Well, what I want you to do is I want you to put this comment block here at the top with your information, but just move it over a little bit so that way the other blocks won't overlap it. But don't move it so far that it moves off the page. You don't want to have to scroll to be able to see the comments. Alright, so we're going to ask the user for some input. So the first thing we're going to do is ask how old the person is. Okay, so this is a comment, so you get in the habit of the forward slashes. Alright, so ask how old they are. The next block is going to compare to see if they're old enough to vote or not. Well, that's going to be an if-then statement, or what's called a selection. Okay, so I have my selection block here, and the purpose of this is to see if person is old enough to vote. Now remember, your comments just simply need to be descriptive enough for anybody else to look at and understand what's going on. Now you'll see that my comment here actually overlaps this node just a little bit, so I'm going to move it just out of the way so that way I can see the whole thing without anything being overlapped. Alright, so we're going to say something like, how old are you? Question mark. And we're going to put this into a numerical value, so therefore I'm going to use the NUM prefix. It's going to be a number, and it's the person's age. So I want to type something descriptive like age. So it is a number that is the person's age. Okay, done. Now, I don't have to do this with Raptor, but I want you to get in the habit of it. If I'm going to use a variable here, I want to declare it. Okay, so I'm going to start off that num age starts off at 0. We won't always start at 0. Sometimes you'll start at 99 or 1000 or whatever, depending on what kind of range we need to try to compare for. But for now, most of the time these are going to start off at 0. Alright, so the number, or the age is 0. We're going to ask them what their age is, and then we're going to put their age into num age, and then we're going to compare it. So the comparison here is if the person is greater than or equal to 18, then they're old enough to vote. Now I am going to incorrectly make it if they're old enough to vote is greater than 18. So what I'm going to do here is my comparison is going to be if num age is greater than 18. Done. And so now what we're going to do is we're going to ask them what their age is. So if they're old enough to vote, then we're going to output on the screen, you're old enough to vote. If they're not, Remember our dual alternative, I have two options here. They're old enough or they're not. And remember I said that Raptor is backwards from the flowcharts in the book. Alright, so I'm going to make an output here and another output here. And the yes side, because its num age is greater than 18, you're old enough to vote. So I'm just simply going to say you are old enough to vote. Okay. So the other side is going to be you're not old enough to vote. Okay, so these are our options. Those are our alternatives. So if the person is old enough to vote, if the person, their age is greater than 18, then they are old enough to vote. Else, they are not old enough to vote. So we have our if, then, else statement. That's a dual alternative. Now, a single alternative would just simply mean that we only have one side. We don't have both of them. All right, so I want to run this, and I'm going to go ahead and step into it. Okay, so right now, num age is 0, and you'll notice that I included this as our camel casing, or lower camel casing, which means the first letter is lowercase, and then the first letter of every word after that is capital. But Raptor ignores that and makes it all lowercase over here. Now, some people were asking about the numbers turning into decimal numbers, and you have no control over that in Raptor. In other programming languages, you do have that control, but in Raptor, you do not. All right, and one other thing, you'll notice that my comment here actually moved off the page, so I want to drag that back in when I get a chance. All right, so are you old enough to vote? We're going to ask, how old are you? All right, I am 21. I'm not really, but let's pretend for this scenario that I am. All right, so I'm 21. Okay, so now what it's going to do is it's going to look at num age. Is num age greater than 18? Yes, it is. All right, so it will go over here to the yes side, and then it will output you are old enough to vote. All right, so I evaluated something that's over 18. Let's do the same thing again. Evaluate, I'm 16 this time. Okay. Okay, now num age is 16. 16 is not greater than 18, so we're going to go to the else side, and you are not old enough to vote. Okay, works the way we expect. All right, so if I come in now, I want to always test my limit. My limit here in this case is 18. So I'm going to test 18. Now I expect that my program should go to the yes side, that I'm old enough to vote. But in this case, what it will look at is 18 is not greater than 18, so therefore we're going to go to the no side. Ah, we have a logic error. Okay, so the way that we fix this is we're going to change this to be num age is greater than or equal to 18. All right, so a very subtle change, but watch what happens now. When I run this, now I'm 18. We evaluate 18 is greater than or equal to 18, so now we're old enough to vote. So pay attention to your comparison operator here, and then also pay attention to your limit and make sure you test it. Now, I did something in here that I probably shouldn't do, and the thing that I did that I shouldn't do is I included the number 18 in my evaluation, and I really want to try to avoid doing that if at all possible. So what I am going to do is I'm actually going to create a variable that is going to go here. I'm going to create what's actually called a constant. Now in Raptor it won't treat it any differently, but in other programming languages it will. And what I'm going to do is I'm going to put another assignment up here, and stop my program, and we're going to call this num voting age. Okay, now voting age is 18. So now what I'm doing here is I'm saying num voting age is 18, and then down here instead of 18 I want to change this to num voting age. Now the reason for this is let's say my program isn't quite this simple. Let's say I have comparisons to the age being 18 in thousands of places in my program, and then at some point the government comes through and says, oh, we're going to change the voting age to 19. I would have to go and touch the locations where I have 18 hard-coded into my program everywhere if I did it the first way. If I do it this way, I only have to change the voting age one time. and it will affect everything in the rest of my program that references this value instead of the number 18. Remember, 18 is a literal. A literal means it literally is 18. And if I come down here and I look at this and I say num age is greater than or equal to 18, 18 is a literal. I don't want to have literals. If I have a number that shows up somewhere in my program like that 18 and I don't really know what it is, then that's actually considered to be a magic number, and that is poor programming design. Alright, so let's move some stuff around. I'm going to put my comments back in here so we can see what they are. Move these comments out of the way. Alright, so now what I'm going to do is I'm going to compare it. This should work the same way that it did before, except now we declare that the number that represents the voting age is 18, and if I ask how old the person is, then what we're going to say is that they are 19 years old. Okay, is the num age 19 greater than num voting age, which is 18? Yes, it is, so we will end up on the yes side. Now, like I said, what this does for me is, let's say 2 years down the road somebody changes the voting age. I just simply come into here, change this value to, let's say, 20, and then now our voting age has changed for all of my comparisons everywhere in my program. So what you want to do is, anytime you have a selection statement like this, or you have a comparison, you don't really want to compare a literal, you want to compare two variables. And so I'm comparing the age that the person entered to the age that I know is legal to vote. Alright, so this program is working, is the way that I want it. Make sure you put all of your comments in here. So this should say declaring variables. This is asking how old the person is, comparing their ages, see if they're old enough to vote, and then when you're all done, save it. Now what you'll notice is that I do have my actual .wrap file. This is my real program, and then I have the backups. Be aware that when you submit this to Blackboard that it has to have the .wrap file. If you just simply upload the .backups, I cannot use those. I have to have the .wrap. Alright, let's go ahead and do the program to see if a person is old enough to drink. Well, it's actually just a variation of this one. So I'm going to go up here to File, Save As, and I'm going to call this number 2 instead of number 1. Alright, and in this one, instead of voting age, we're going to have a drinking age. Alright, so in this one, we're going to say drinking age is 21. And this time, it's not old enough to vote, it's old enough to drink. By drink, I mean to consume alcohol, but we're going to ask a person if they're old enough. Alright, so how old are you? It's still going to be the number age. And here are condition changes, so that instead of num voting age, we're going to do num drinking age. And then down here, instead of you're old enough to vote, you're old enough to drink. And then this one, you're not old enough to drink. Okay, notice that I didn't specify 21 in here. I'm using the variable. I want my condition to be one variable compared to another one, if I can make it that way. Alright, so when I run this, just like before, I'm going to evaluate my limit, one above it, and one below it. So I'm going to do 21 because I know that's my limit. Okay, so are we old enough? Yes, we are. Okay, so that's working. Good. So let's try one above it. Okay, so this time 22. I should still be old enough. Yes, that's working. Great. Okay, so now I'm going to do one below it, 20. Run it, and I'm not old enough, and now that's good. So make sure whenever you do any of these comparisons, you always test the limit, one above it, and one below it. So I'm going to run my program 3 times to make sure that it works the way that it should work. Alright, so that's it for this one. So go ahead and just save it. That's number 2. Alright, let's go ahead and make number 3. Now number 3 was to see if a person gets a discount. And who gets a discount? Well, somebody that's under 3 or over 65. So if you're 3 or under or 65 or older, then you get a discount. So anybody from 4 to 64 does not get a discount. Alright, so what I'm going to do is I'm going to make a new Raptor flowchart, and I'm going to immediately save as, and then we're going to call this number 3. Okay, so now we have number 3. Alright, so what I'm going to do is I'm going to first, just like the other one, ask how old the person is. And so what we're going to do is we're going to assign a variable to hold their age. So we're going to call this my age, and we're going to set this as 0, because that's what we assume they're going to input. And then we're also going to make 2 more. Now these are going to be what are called upper and lower limits. Now my upper limit is 65, my lower limit is going to be 3. So I'm going to say, in this case I have num upper, and I'm not going to call it upper limit, I'm going to call it upper age. And we're going to set this equal to 65. And in this case I'm going to say num lower age is 3. Because now what I want to do is compare if the person is over 65 or under 3, then we're going to give them a discount. Alright, so the next thing I need to do is ask them how old they are. So, how old are you? And put that into num age. Oops, I typed in my age. Num age, sorry. Alright, so num age is 0. And so we're asking them how old they are. We're going to put that value into num age. And then we need to do a comparison. Are they old enough or young enough to get a discount? Okay, so I want to make this where if they're old enough or they're young enough, then we get the discount. So before I do that, I'm going to put my outputs here. So this side is going to be you get a discount. This side is going to be sorry, no discount. Okay, so what I want to do is I want to evaluate this such that we go to the yes side if they get the discount. Alright, so what I'm going to do is I want to see if the person is 3 or younger. So if num age is less than or equal to 3, which 3 is our num lower age, so num lower age. And then what I want to do is I want to see if they're either younger than 3 or they're over 65, then we give them a discount. Well, if it's one or the other, then I'm going to use the word or. So if num age is less than or equal to num lower age, or num age is greater than or equal to num upper age. So now what we're doing is we're checking to see if this is true on this side, it'll be true. Or if this is true on this side, it'll be true. Or if both of them are true, it's true. But if both of them are false, then it's false. So if either one of those or both of those is true, then we'll go to the discount side. Alright, so that's it. So I'm simply going to run this. We're going to put in our declarations here, so we're declaring our values. We're going to ask them how old they are. Okay, so now, in this case, what I'm going to do is I'm going to put that I am 2 years old. I'm going to test my limits. Now, remember I said test the limit, test one above it, and one below it. You're actually going to do that for both of them. So I'm going to do 6 evaluations now. So this is one below my limit, so 2, I should get a discount. Alright, so click OK. Now, the way that this will work is it'll say if num age is less than or equal to num lower age. So num age is 2, num lower age is 3. This 2 is less than or equal to 3, so that's true. So therefore, it's immediately true. Now, here's the trick. In most programming languages, it will just stop the evaluation right there, because if this first thing is true, then it immediately goes to the true side. It doesn't even bother looking at the second one. And the reason they do that is to increase efficiency of the program and make it run faster. But that may not always be desirable. So if it's more likely that this first thing is going to be true, then I'm going to leave that as the first one. But if it's more likely that the second one evaluates as true, then I want to put that one first. So you just have to look at your program, and whichever one's going to be more likely to evaluate as true, list it first. Alright, so now they're 2 years old. This is true, so we should go to the true side. You get a discount. Great. Alright, so we got a discount. Okay, like I said, test my limit. So I tested 1 under, so I'm going to test 3. I should still get the discount. We do. Test again. I'm going to do 1 above my limit, which is 4. I should not get the discount. Sorry, no discount. Alright, so then I'm also going to go through and test my upper limit, and my upper limit is 65, so I'm going to start with one below it, so 64. I should not get a discount. Alright, so then run it again, test that limit itself, so 65. I should get the discount. Great. And then do it one last time, and one above the limit, which is 66, and I still get the discount because I'm old enough. So make sure that you test the number above, the number below, and the exact number for a limit for each of your conditional statements that's in here. So if I were comparing 3 sets, then I'd have to do 9 comparisons. So you're always going to have 3 comparisons for each conditional statement. Alright, so that's it for this one. You need to include all your comments, explain what everything does, save it, and then we're going to do another one. Alright, so the next one I'm going to break a rule that I just said about, and the reason for it is just to make it a little easier to follow along. The next program that we're going to do is the one that I talked about where we try to figure out what a person's grade is. Alright, so what I'm going to do is make a new one. I'm going to save it as number 4. And here's my program. Start your comments, and then we're going to start the program. Okay, so what I'm going to do is I'm going to ask the person for their grade as a numerical value. Alright, so what I want to do is I want to make sure that they enter a grade. So the way that I do that is by telling them to enter the grade. Alright, so what I'm going to say is enter a grade between 0 and 100. Alright, and then they enter that grade, and we're going to stick that into num grade. Okay, now this is our num grade. We're simply just trying to figure out what their grade is, and then click done. Alright, so here we're using this variable, so I need to make an assignment for it. We're going to declare it. So num grade, and set that equal to 0. We're going to assume to start with that they got a 0. Okay, well here's the catch. I'm going to start off comparing to see if they got an A or not. I want to know if they got an A. So I'm going to assume they got an A to begin with. So if that's what I'm going to assume, then I should probably start this at 100 instead, because I'm going to start evaluating at 100 to 90. Then I'm going to evaluate from 89 to 80. Then I'll evaluate from 79 to 70 and so forth. So if I'm counting down in my evaluations, then I want to initialize this variable location at its upper limit. Alright, so I am going to ask them for the grade, and then we're going to perform a selection statement. And my selection statement is simply going to be, is their grade between 90 and 100? Well, actually, in this case, I could get extra credit. So let's say somebody enters 105. I need to account for that. We'll come back to it. We will account for that in just a minute. But for now, what I want to do is I want to evaluate, is their grade between 90 and 100? So what I'm going to say is, if the grade is greater than 90 and less than 100, and actually if it's greater than or equal to 90 and less than or equal to 100, then they got an A. Alright, so I'm going to say if the grade is, if num grade is greater than or equal to 90 and num grade is less than or equal to 100. Notice I'm putting a space between the variable and our comparison operators. Please get in the habit of doing this. Alright, so what this does is if the grade is greater than or equal to 90 and it's less than or equal to 100, then they got an A. Alright, so what I'm going to say here in my output is the grade is A. Alright, so if they didn't get an A, then they got something lower than an A. So then the next thing that I want to do is evaluate, did they get a B? Well, if I'm going to do another evaluation, then I actually need another selection statement. And what I can do is I can nest these. So I'm going to put another selection statement inside of the no side of this one. Because if they didn't get an A, then they may have gotten a B. So I want to see, did you get a B? Alright, so what I'm going to do now is I'm going to say, is num grade greater than or equal to 80 and Now, here's the catch. I can't set it less than or equal to 90 because if they got a 90, then it actually would be an A. So if num grade is simply less than 90, so if it's greater than or equal to 80 and it's less than 90, then the grade is a B. So we're going to put that on the screen. So we'll say the grade is B. Done. Alright, so now you're going to notice very quickly that this is going to get kind of wide. Now, in some of our modern programming languages, we can actually use what's called a case, which is a very shortened version of this cascading selection statement. But in Raptor, this is the only choice that you really have. So I want to compare, did you get a B? No? Alright, so then they got something else. Well, we need to compare. Now the next one here is going to be, we need to find out did they get a C or not. So if they got a C, then that means that num grade is somewhere between, so greater than or equal to 70, and num grade would have to be less than 80. Okay, so then if this is the case, then we can output the grade is B. I'm sorry, C in this case. Done. Scroll over. Okay, if it's a C, great. If it's not, then we need to do another selection because we're still trying to figure out is it a D or an F. Alright, so if the grade is between 60 and 70, then they're going to get a C. I'm sorry, a D. Alright, so what I'm going to do here is I'm going to say is num grade, in this case, is going to be greater than or equal to 60, and num grade is less than 70. Okay, so in this case now the grade is a D. Alright, done. Okay, scroll across, and now I can do something like put another selection statement here. But if you notice with this cascading selection statement, they didn't get an A, they didn't get a B, they didn't get a C, they didn't get a D, so the only possible other grade that they can get is going to be an F. So my very last one, I'm just simply going to state over here that the grade is F. Now I could have done another selection statement here, but that just makes for more symbols on the screen and more evaluations to occur, and I don't necessarily need that. Okay, so this is all that our program is going to do, is it's simply going to output on the screen if we got an A, a B, a C, D, or an F, and then we're done with the program. Alright, so I am going to make this a little bit smaller so it'll fit on the screen better, and what we can do is we can watch it run through the program. Alright, so we start off, we declare a num grade at 100. We're going to assume they got 100 to start with. Hopefully they got 100 in the class. Alright, so they got a grade, enter a grade between 0 and 100. Alright, so I enter, let's say, 96. We'll start off with an A. Alright, so go ahead and click OK. Alright, so now what it will do is it'll compare, is num grade greater than or equal to 90? Well, it's 96. That's true. And is num grade less than or equal to 100? Well, that's true. So both of these are true, therefore it's true, and it'll go to the true side. Okay, so that's okay. Alright, I want to evaluate my limits, so I'm going to do 89, I'm going to do 90 and 91, I'm going to do 99, 100, and 101. Okay, now here's the thing, if I test above my upper limit, watch this, I'm going to do 101, go ahead and click OK. Now, is 101 greater than or equal to 90? Yes, that's true. And is num grade less than or equal to 101? Ooh, no, it's not. So what will happen is it will go into the B. And it's not between 80 and 90, so it's going to go to the C. Nope, it's not between 70 and 80, so then it go to the D. Nope, those don't work, so I would have an F. Let's watch this. It goes to the B. It evaluates. It's not between 80 and 90. It goes to C. It's not between 70 and 80. It goes to the D. It's not between 60 and 70. And oh man, my 101 score, I got an F. Alright, so something's wrong with my logic. Alright, so what I'm going to do is I'm going to simply remove this. section here where we want to evaluate if it's less than 100. So what I'm going to do is change this. I'm going to get rid of this, because if we got anything greater than a 90, then that's an A. It doesn't matter. It could be 1,000. And as long as it's greater than 90, it's an A. Alright, so now watch what happens. If I run this again and I set my score to 101, alright, so now it's greater than or equal to 90, therefore it will evaluate as an A. Alright, so now the next thing I want to do is I want to kind of make these a little better. Alright, so my evaluation here for the B, make it bigger so you can see it. My evaluation for the B is the grade greater than 80 and less than 90? Well, the question is, if I got to here, don't I already know that the grade is less than 90? So if that's the case, I don't actually have to evaluate the 90. I just simply am evaluating, is it greater than or equal to 80? All right, let's try this. All right, so I'm going to delete this, and so I'm just simply evaluating, is it greater than or equal to 80? And the reason that I'm doing this is if I come through and let's say I type in 86. Well, then what I'm doing is I'm evaluating, is it greater than 90? Nope. Okay, let's go down here. So if it's not greater than 90, the only way to get out of here is if it's not greater than 90. All right, so now I come down to here, and now all I have to evaluate is it greater than or equal to 80. All right, so let's run it. All right, I enter 86, click OK. This is not true, so I'm going to end up on the no side. So I don't have to evaluate for the 90 in this particular scenario. Just be aware of this when you do your cascading selection statements. A lot of times you can make your code shorter just by simply doing away with some of your evaluations. Okay, so the same thing occurs here. I don't have to evaluate, is it greater than or less than 80. I just need to evaluate, is it greater than 70, because I know if I got to here, it is definitely less than 80. Same thing when I come over here. I'm simply trying to evaluate, is it greater than or equal to 60? I don't care about if it's less than 70, because the only way I got to here is if it was less than 70. And now my code is actually a little bit more efficient, because before what it would have to do is it have to evaluate both conditionals, then it has to do the truth table to figure out if it's true or not. And in this case, we're just simply going to say, is it greater than 90? Nope. Is it greater than 80? Nope. Is it greater than 70? Nope. Is it greater than 60? Yes. Oh, you got a D. And it just makes it real easy for our program to go through and evaluate, and it also makes a lot less evaluations for us. Because remember, I said test your limit, test one above and one below. That means 3 here, 3 here, 3 here, and 3 here. Well, that's 12 right now. If we had both of the conditionals before, we'd actually have to do 24 evaluations to make sure that our logic is correct. So not only does it make our program smaller and more efficient, it also makes our testing faster because we don't have to test all those different areas. Alright, so I'm going to go ahead and save it, and we're done with this one. So in this lesson, you learned that any decisions that you make are going to be based on a Boolean expression. We're going to compare two values of the same type together. So I want to compare two numbers, or I can compare two text strings as long as they're both text strings. I need to use ands and ors, and then make sure you're aware that the and decisions actually evaluate first before the or decisions. The ands, both parts of the conditional have to be true. The ors, either half has to be true. And if I want to change the order of how those get evaluated, then I'm going to use parentheses. If I want to do a range check, I'm just simply comparing a range of numbers. Make sure you know to have the lowest number in the range and the highest number in the range. And by the way, when you get into the program with actually evaluating for the ranges, make sure that you declare variables to hold your limits. So your comparison shouldn't be, is the grade higher than a 90? It should be, is the grade higher than a num A or something like that, and then set that to 90. So make sure you do your range checks, compare the numbers. We're going to compare the highest and the lowest. We don't always have to do the ands and the ors in those. Sometimes we can get away with those, and when we do, it makes our code more efficient, and it makes it easier for us to troubleshoot and also perform our testing.